Welcome, students. Welcome. Today we are going to talk about air all around us. Suck in that good air. What is air? What's inside air? And let's do some experiments. Let's get straight into this. Okay, so this is going to be all about the composition of air. The word composition means what's it made up of, right? So some of you might have seen this in previous textbooks before. Let's get a nice pen. That air is made up of different elements like nitrogen, oxygen. We've even got these cool elements like argon, and of course the one that's not so good for our environment is carbon dioxide, which is on the increase at the moment. So you've seen in textbooks that there is a certain percentage. So we've got 78.1% of the air around us is nitrogen. We've got 21%, which is our oxygen, and then a small percentage is a noble gas called argon, and then even smaller percentage is carbon dioxide. So this, unfortunately, is something you're just going to have to go and remember. And yeah, it's just basically a whole bunch of scientists have figured these things out, and in the exams, they just want you to know the percentages. Today, we're actually going to do a few experiments where I'm going to show you how the scientists figure this out. And we're going to use this little kitchen item. I wonder if you can have a little zoom in on that. This is an item called steel wool, and you use to scrub your dishes with. But it is actually a piece of equipment that you need to test the percentage of oxygen in the air. So I'm going to go and show you that experiment now. Before we get to that, let's just go back to this. Let's just mention that when we talk about air and we talk about these percentages, we are talking about dry air. We are talking about unpolluted air. Okay? This is really important because most air will have some kind of pollutant in it, and most air will have, some kind of 0 to 4% kind of water vapor. This is coming from water bodies like lakes or just rain that's on the road or whatever. Also, we must mention at this point that there is an increase in CO2, and this is caused by the burning of fossil fuels, and we know this with climate change. Okay, so that's something that I wanted to mention. Now, let's go on to talk about this experiment. So this is an experiment where you are to find out, to determine the percentage of oxygen in the air. Okay, oxygen I'm just going to say in air. Okay, it's all about air. So just underline it nicely. Okay, cool. So what they do in this experiment, stay with me, is they take a nice sort of bucket. Okay, let's just get a nice little bucket here, and they fill it up with water. Let's get some water. Let's get a nice sort of big one. Okay, so here is my bucket full of water. And what they're going to do is they're going to put a boiling tube inside this bucket of water. Okay, you're going to put a boiling tube inside this water. They are going to know how much water is in this bucket. They're going to measure that. Okay, so they know that the water level at exactly this mark here, this is how much water is inside this bucket. Now, what they're going to do is they're going to take this little piece of steel wool and they're going to put it at the top of this boiling tube. Now, sometimes they'll just use a little bit of Vaseline or something to stick that at the top of the bucket. Now, what is steel wool? So what is this, what element is this? Well, it says steel. What is steel? Well, steel is a combination of iron and carbon. And in fact, this one that I'm using now is just made up of iron. Okay? So it's really important to understand that this thing here, this is iron. Okay, and iron, we know, has the symbol Fe. Now, iron, if you left iron just normally if you left it out in the environment, if you left this piece here on my desk, iron would start to turn an orange color. And we know the reason for this. We know that this is because iron, sorry, let's just stay back on the whiteboard. Iron can combine with oxygen to form iron oxide. Now, iron oxide is otherwise known as rust. It's that orange component. Now, what will happen is, because if you think about it, in this portion of the boiling tube, in this section here, there is air, and inside that air is oxygen. And what's going to happen is this oxygen, these little O2 molecules, are going to combine with the iron. And if they combine, it's almost like, just watch here, it's almost like, ooh, it's not letting me do it, but it's almost like they're disappearing. Okay, they're disappearing, and they're disappearing, and they're disappearing. And if they disappear, I'm just going to neaten this up a little bit. If they disappear, what it means is that there is becoming space available. So if you think about, here's an O2 molecule, it's now joined up with the iron and it disappears. Okay, what does that mean? It means that there is now space for something to go, and we've got water here. So what's going to happen is the water is going to start to rise. Okay, it's going to start to rise, and it's going to start to rise, and now we're going to have a new water level. There's going to be a new water level here. And what they can do as scientists, they can think about this and they can go, well, let's leave this for 2 weeks until all of the iron has taken up all of the oxygen in this space. And the water has not risen anymore after 2 weeks. Then what they can do is they can take whatever this reading was, say this was 100 milliliters of water over here, and they can take this new level, this new reading will be 121 milliliters. And what they can say now is they can say, well, hang on, how much space was taken up? Well, all we have to do is say 121 minus 100, and we'll get 21 milliliters. And this number is how much space was occupied by that oxygen. And therefore, if 21 milliliters over 100, over the original water level, you could times this so you can get a percentage. And that percentage is roughly 21%. And this is what we went back to when we talked about the percentage of oxygen in air. We said it's 21%. And this is where it comes from, people. It comes from this experiment. Okay, now there are other experiments that they can use to prove that oxygen has a composition of 21% in the air. So I thought I'd just show you this really simple one. This is using iron. In IGCSE, you will also learn about an experiment that uses another element, copper. We're not going to go into it now, but I thought that this would be quite interesting for you guys to have a look at. I hope it's been really helpful, and this is the composition of air. It's as simple as that. See you next time.